Anything about specific right triangles? For example, when you see this right here, when you see this one, 12, 9, and 9, 12, and how do you know it's 15? Like, how did you know that off the top of your head besides the fact that you used the Babylonian theorem? Do you remember?
3, 4, 5.
It's just a multiple of a 3, 4, 5 triangle. It's a multiple of a 3, 4, 5 triangle. So if you divide, like this divided by 3, you get 3. This divided by 3, you get 4. So 5 turns into 15. Whenever you use the Babylonian theorem and you get a, quote, nice third side, it means that it's a multiple of some Babylonian triple. So you will have to find it. So what does it mean when it says solve each? What does solve mean in the context of this question? Do you remember what that means, Jax? Yeah.
Find the opposite sides.
Find the what?
The sides that are blank.
Find the what?
Sides and angles that are blank.
Blank. Sorry, that's what you said, blank. Yeah. So find the missing sides and angles. Absolutely. So for example, in this one, you need to find the green side, you need to find the purple side, and you need to find that angle value right there. So when it says solve, just to be clear, that means find the missing angle and side lengths. Find the missing angle and side lengths. They're up on the board right there. You can try those by yourself. I'm going to give you like 2 minutes to do that. 2 minutes to do this one right here. Functions. Jax, yeah. Yeah, so you literally just write down sine, cosine, and tangent of theta on these right here. And I'll put this down below so that we have some more space here. So sine, what's sine going to be, Jax?
I got 9 over 15.
Yeah, it's just 9 over 15. What's cosine?
12 over 15.
Right, and then tangent is?
3/4.
Yeah, don't so on these right here, this is really important, everybody. On the test or quiz, it's really important that you don't simplify these unless you have to, because it's much easier for me to identify you did the right fraction, Jax. So just keep it as 9 over 12. That is correct. It wouldn't be wrong. You would get full credit. It just takes me an extra couple seconds, and then when you multiply that by the whole class, it can matter. So then when you get these 3, how do you find the other 6 really quickly? What's the thing you list out first? Yeah, so this is cosecant of theta, this is secant of theta, and this is cotangent of theta. I did this a bunch in the video. You just flip them. So it's 15 over 9, and then 15 over 12, and 12 over 9. This gets really repetitive when you do these 6 trig functions. It should be really repetitive. And yes, you should know 7, 24, 25. Do you do B the exact same way, everybody? Yes, don't change anything. It's just different numbers, but don't do decimals on these. For solving these triangles, though, which of these two are these trig values, 25 degrees and 50 degrees? Are those trig values that have like nice trig answers? Are those trig values, are those angle measures on the unit circle that you've seen before? No, they're not. So do you expect these to have decimal to 3 decimal places lengths? Yes. Yes, you do. So let's do one of them. Solve each of the following triangles. What do I need to do first? How do I go about doing this? Anybody remember what I did in the video to do this first one? Yeah, Sophie.
Find the other angle.
Exactly. How do you figure out the other angle? We'll call this alpha.
90 minus 25.
Yeah, so I'm just going to go back a step. So it's alpha plus 90, plus, because of the 90 right there, plus 25 is equal to? Because the interior angles of a triangle add up to 180. So alpha is going to be 180 minus 90 minus 25 degrees. So what's alpha going to be? You can do this in your head. What is it? 90 minus 25 is? 65. So this is 65 degrees. Okay, so what next? What do we do next?
I would set sine of 65 or something off to something that uses the 15.
Something that uses the 15?
Yeah.
Sure. So you want this x to be hypotenuse? Sure.
Yeah.
So you want x right there to be hypotenuse. So this is the x value right here. Okay, I'm going to unhighlight that. So here's x. Okay. So this is x, like this?
Yeah.
So what did you say? You said cosine of what?
65 degrees.
65 degrees is equal to what?
Equals 15 over x.
Yeah, 15 over x. Sure. Okay. So then can you solve for x now?
Yeah.
Yeah, you can solve for x. Absolutely. So x is equal to 15 over cosine of 65. Is that something you need a calculator for?
Yeah.
Saving grace for trigonometry is that sometimes really ugly trig things simplify nicely with identities, and sometimes they just plug them into your calculator. Is 65 degrees something that's on the unit circle that you have seen? No. So what will you need if you want a decimal? Calculator. So this is one path. Are there other paths through this question right here? Yes, there are. It's okay if it takes a little longer because you can get there and you're fine. If you do this, what did you get, Jax, for x?
35.493.
When you get answers on these triangles, I would like you to take 2 seconds to think, could that realistically be 39.493? Realistically. Sure. It's not like a billion. Like if you got a number that was like 68,980, would that be a problem? Yes. Now here's another question for you. I'm going to do this again here. We had this triangle. Here's the original triangle we had. We had 25 degrees and 15 right here. Is there a trig function that uses that angle measure and a missing side? Do we have to find the 65 degrees right here to do this one? No. What trig function do you want to use, Sophie? Yeah, if we did sine of 25 degrees, and that's x right there, what's sine? Sine of 25 degrees would be what? 15 over x. So what is x going to be? 25 degrees. Do that on your calculator. What do you get? Someone do this right now on your calculator. Verify for what should we get for this one? Yeah?
32.168.
Hold on. Careful. It's the same side. It better be the same number.
Oh, the same side.
I asked you, like, for this one, x is the same thing. It's the same x right here, right? 15 over sine of 25. What is it, Sophie? Or somebody else? Is it the same thing? Should it be the same thing? Yes. If it isn't the same thing, what does that mean? If we didn't get the same decimal, what would that mean?
Wrong.
Something's wrong, right? Something's wrong, but we're not. We're correct here. So, Jax, you're absolutely right, and Sophie, you're absolutely right. We could do it in terms of the 65 or the 25, but you can start other places if you want. Does this make sense, everybody? So now that we have this side, we're not done yet because we have the angle measures and we have x. What other side do we need? We need the base, right? We need the base. What trig function do you want to use for the base? How do you want to do the b? Yeah. Cosine of what? Sure, cosine of 25 is equal to? Careful, cosine is adjacent over hypotenuse, so b over? Yeah, so 35.943. So here is a tip, everybody. This is super important. Everybody, do you know about the store button on your calculator? Do you know about the store button on your calculator, Sophie?
I just think it's 0.493, not 9.
0.493. Thank you. That's really important. So it's 0.493 right here. Everybody, this is important. Is this right here? Is this rounded right here? 0.493. Did you round to get that answer? Yes. Did you round at the end there? Yes. But is this the end of this question right here? No. If you don't round at the end, what you get can be a little bit off. So here is something you need to see. I'll put it up there. Here it is. Down in the, where is it? STO. Find the STO button on your where is it? Right there, STO. If you have a number written into your calculator and you have an STO, you can save it as a letter, and then it'll save that decimal. You can then save the really long decimal and then use it later. It's super helpful because you want to round at the end. So if you do this out, what does B equal? B is equal to 35.493. It goes on times cosine of 25. What does B equal? Who has B for me? Yeah, what did you get?
I got 32.168.
Yes. Here's the deal. If you round not at the end, you can be off, especially if you're going to 3 decimal places. Round at the end if you can. Please, 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 round at the end. Round at end. If you don't know how to use the STO button, I'll come around and show you. You have some number written out and you hit STO. I will show that to you. With the person next to you, solve B. You can tell me what's going on here. So we have our base here, the green one, and then we have the height here. Anybody have the blue height? Anybody have the blue height for this one? The blue height. Yeah, what do you get, Sophie?
12.856.
Anybody agree with 12.856? Anybody agree with 12.856? Okay, excellent. What about the base? Who has the base? Someone else. The base. Someone different. Yeah, go ahead.
15.321.
Who has 15.321? You got that? Nice. It does feel kind of nice to get like actual numbers as opposed to theoretical, like wavy, magical things that really could be some math. We could write our own like YA young fiction about like a math universe. That'd be fun. So, and then we have our alpha value right there. What's that base? That's just subtraction, right? What's that base going to be? 40 degrees. 50 plus 40 is 90. Yay. So are we done? Yay, we're done. See if you can figure out the cleanest, shortest way to do this one. What's the cleanest, shortest way to do this one? Who wants to go here? Yeah, Sophie. 2 what? Point 261. People agree with that? And what trig function did you use there? You have a choice there. Which one did you use? So cosine of 13 degrees is equal to 200 over x. Do people agree with that? So is it generally straightforward? Yes. What's the nice thing about these triangles that make this straightforward? There's a specific thing about these triangles that we've worked with. All of these triangles are? Right. Yeah, they're all right triangles. Is that key? Yes. Are we always going to be dealing with right triangles? No, that's what's coming next. And it's not that bad. It just changes. But yes. Here's the thing, everybody. Here's the thing. It just changes what formula you use. The only real difference here is there's no picture. Draw a picture of what's going on.